Okay, welcome to day 7. Homework is to begin working on the problem set number 3. So after today, you should have a good idea of how to work with that. We are going to be in notebooks for the entire period. And here's our first one. So we want to find on what intervals is f increasing and decreasing. Now, whenever you're given a graph in this course, I want you to take 10 seconds and tell your group mates what should you look for anytime you are given a graph in this course. Hopefully you said something like you should look and see what type of graph it is, or see if it's a F graph, an F prime graph, F double prime graph. Because depending what type of graph you're given, it tells you completely different information. So we want to know on what intervals is f increasing and decreasing. Well, we know from our videos that f increases when the derivative is positive, and f decreases when the derivative is negative. And that's because a positive derivative means f has a positive slope, and a negative derivative means f has a negative slope. So we're given the graph of f prime. So let's draw our number line. Our critical values are places where the derivative is 0. So we've got at 1 and at 5. So down here, these are values of x, and up here, we're going to be putting values of f prime of x. When I say values of f prime of x, we're going to be doing positive and negative. Well, but before 1, the graph of f prime is below the x-axis, so it's negative. Between 1 and 5, the graph of f prime of x is above the x-axis, so it's positive. And from 5 and onward, it is then negative. So this then allows us to do part A and identify where f is increasing and decreasing. F will increase where the first derivative is positive, so on the interval from 1 to 5. And we will decrease where f prime was negative. So in our case, we didn't start until 0, so we are from 0 to 1. And then the u means the union, and then again from 5 to 6. So for part B, we want to know where does x have a local max and local minimum. Well, at 1, we are going from a decrease to an increase, so that would be a min. So a local min at, oops, actually we just want to know the x value because we don't know the original function to find the y value. And at 5, we switch from increasing to decreasing, so that would be a max. So this is x equals 5. And this is what's called the first derivative test, when we use the first derivative to determine where there are local mins and local maxes. So now we're going to do the exact same process, but instead of having a graph of a derivative, we're given the equation for f. So we'll go ahead, we'll take our derivative, f prime of x. We'll get 6x squared plus 6x minus 36. We'll find our critical values. It's a quadratic, so the derivative exists everywhere. So we just want to see where the derivative is 0. Notice everything has a 6 in it. It's important when we're doing this that we don't divide that 6 out, that we just pull it out front. The reason being, it's not a big deal when it's a positive, but if you were pulling a negative out, that would play a role in the value of your derivative being positive or negative. So just pull that out. Don't divide it over. We want to multiply to negative 6 and add to 1. So we should have x plus 3 and x minus 2. We'll get x equals negative 3 and x equals 2. Nothing for the 6 because there's no x values. We'll go to our number line. We'll put those critical values on there. Those are x values, and we're going to do test values in the derivative, f prime of x. So remember, all we care about is negativity or positivity. We don't really care about the actual number. So something left of negative 3, think like negative 10. Well, we have the 6, which is positive. When you put negative 10 into x plus 3, you get back a negative. When you put negative 10 into x minus 2, you get a negative. A positive times a negative will give us a positive for this section. So because all we care about is positivity or negativity, when I'm on the outside, often I'll pick a really extreme value. So for that one we just did, sometimes I'll pick like negative 10 million. Because I know when I plug negative 10 million in for each of those x's, both parentheses are definitely going to be negatives, because negative 10 million is so enormous. It's just easier for me to think about. And that middle one, the easiest value is probably 0. So when we put 0 in, the 6 is positive. And we get positive when we put in 0 for x in the middle parenthesis, and then we get a negative. Positive times a negative is a negative. And then something to the far right, say like positive 10. Well, the 6 is positive. 10 in for x with the x plus 3 is still positive. 10 in the x minus 2 is still positive. 3 positives multiplied together give us a positive for our derivative value. Subbing in the factored form is much, much easier than subbing in the non-factored form of the derivative. So we can do part A now. We are increasing where that derivative was positive. So from negative infinity to negative 3, and then again from 2 to infinity. We are decreasing from negative 3 to 2. For part B, at negative 3, we switched from an increase to a decrease. So that's a local max that is happening at x equals negative 3. Now notice this one did not say just find the x values. We want to find the actual local maxes and mins. So we got to find the y value that goes with that negative 3. We'll get that in a second. At 2, we go from a decrease to an increase. So therefore, that is a min. And that's happening at 2 comma something. Now maxes and mins are points on the actual function. So when we go to find these values, they are y values, so they're on the actual function. So when we sub in negative 3 cubed will give us negative 27, times 2 will give us negative 54. Negative 3 squared will give us 9, times 3, which will give us 27. And negative 3 times 36 will give us a positive 108. Well, negative 54 and 108 is positive 54. Add 20 to that, you get 74. And add 7 to that, and you'll get 81. Subbing in 2 to the third is 8, times 2 is 16. 2 squared is 4, times the 3 will give us 12. And 2 times the negative 36 will give us negative 72. Well, the 12 and the negative 72 will give us negative 60. Negative 60 and 16 will give us negative 44. So again, those went into the actual function f because they're points on the real function. All right, we're going to have you try this one, number 11, on your own. We're going to pause the video for a bit and have you go through, do the whole thing on your own. If you get stuck, please ask the members of your group to help you out. All right, let's talk about this number 11. We got derivative 4x cubed minus 4x. You can pull out a 4x, leaving you with x squared minus 1. Set those b to equal to 0. You get 0 and plus and minus 1. Put those on your number line. The bottom numbers are x's there, and our tests are coming from f prime of x, subbing in the factored form. Now, if you wanted, you could have made this even easier on yourself, doing 4x, x plus 1, and x minus 1, and that would have maybe made life easier when you're subbing in. You should have got minus plus, increasing negative 1 to 0 and 1 to infinity, decrease negative infinity to negative 1 and 0 to 1. Local max, we were 0 to 3, and local mins at negative 1, 2, and 1, 2. Now, when subbing those in, notice that we had an even function. All the exponents were even, and then we had a constant. So once you sub the 1 in, -1 should give you the same thing back because they'll give you all positives. Okay, so this last one we're going to give you a few minutes to try. Notice it doesn't tell you have to state the intervals of increase and decrease, but we need to find those anyway to find the local maxes and the mins. So we're going to pause the video again to give you a chance to work on this. If you have trouble, ask your group members for help. All right, so going through this number 19, take your derivative, 5x to the fourth minus 5. I pulled out a 5. Set that equal to 0. Don't forget to do a plus or minus when you go to do the fourth root because it's an even root. The -1 and 1, those are x values on our number line. Our tests, the pluses and minuses, come from the derivative, subbing that into the factored form. Now, if you wanted to, you could have factored this further into x squared plus 1 and x squared minus 1. The x squared plus 1 would give you imaginary solutions. We don't put those on our number line. But the x squared minus 1 would give you the plus and minus 1. So it's your choice if you wanted to factor that further to make it easier to plug in. We ended up with plus minus plus, so at -1 we go from an increase to a decrease, giving us a local max at -1, 7, and at 1 we went from a decrease to an increase, giving us a local min at 1, -1. We got the y values for those maxes and mins from the original f of x because they're points on the actual graph. All right, so that's it for this video. Any time left in the period, you can help yourself to one of the textbooks over on the shelf. If there's not enough textbooks, please take a picture of the problems and let another group use it or group together and share.